Gentlemen, we're going to start by taking a look at proving figures are congruent using rigid motion transformations. So the idea here is that if we use rigid motion transformations, our rigid motion transformations are our translations, reflections, and rotations. If we use all three of these or any of these three, we know that the shape we start with is going to be the same congruency, same size, same shape, will be the same size and same shape as the one that we end with. So if we look at this first problem here, when we just add or subtract numbers to the coordinates, this is a translation, and this is a type of rigid transformation. So we know that these two shapes are congruent. So yes, they are congruent in this case because all we did is translate. If we look at this next example here, or this next problem, are the triangles congruent? Well, how did we get there? To answer this question, we just have to know how we get there. And we can tell that I move from A to P via translation. So again, yes, they are congruent because, and this is the important part, because we only used rigid transformations. And we'll just call it transformations. And in this case, we used a translation. Okay. So that's all I really want to show you from these two examples for the moment. Let's take a look at some different problems on the other side. Okay, so now we're looking at two different triangles again, and we want to decide if they are congruent. And we know they are congruent if we use a series of rigid transformations. So we need to ask, how do we move from one to the other? And I'd like you to pause, actually this video should pause for the Edpuzzle, and I'd like you to try and answer question 1 here. Are they congruent and why? Okay, assuming that you've answered that question, I'll take a look at those answers in a little bit and give you some feedback. We know that these are in fact congruent. Yes, they are congruent. Yes, they are congruent. And we know that because we can move, let's see if I can write, can move from triangle ABC to triangle, let's see, it would be MPN, or MNP, I'm sorry, MNP. They should correlate, right? So A should correlate with M, B should correlate with N, and C should correlate with P. So we know that they're the same, the order is the same. So this is an N here. Pretend that that's an N. By, and how do we move there? Well, if we follow this, if we create a little bit of a triangle here, I can translate this whole triangle. I can just kind of slide it over. And if I slide it, I can say I'm translating from A to M. I would go to the right. So my vector would look like this. I would go 1, 2, 3, 4, 5 to the right. And then I would go 2 down. So we would say this is a -2. So I could write this as a translation along a vector of 5 to the right and 2 down. Okay, now that you have a little bit of an idea of what we're looking for, why don't you try number 2 and give me a short answer in this Edpuzzle. Okay, now that you gave that a shot, I will tell you right now that congruence means exactly this, same size and the same shape. Are these the same size? Well, clearly, no. Not same size. Now they might be the same shape. It looks like they both got right angles, and these angles could be congruent. But since they're not the same size, they are not congruent. Let's take a look at a couple more here, see what we can get through for you. Go ahead and pause the video and try problems 3 and 4. It says, for each pair of congruent figures, specify a sequence of rigid motions that maps one figure to the other. So we are looking for a couple different transformations here. Okay, so while I look at this problem number 3 here, I need to notice which points relate to which in each triangle. And it looks like this D is a little bit closer to E, so I've got 3 on the bottom here, and the D is closer to the E. We've got 3 on the bottom here, and the A is closer to C. So we know that if I'm going to name this triangle A, B, C, the corresponding triangle, A would have to correlate with D, because that's the top point here, and then B would actually correlate with F, because it is the point that is 3 down and 2 away. So 3 down, 2 away, that's F, which means this would be E. Okay, so now that I have the orientation figured out, it looks like I need to kind of flip this, right? So the orientation needs to change. E needs to go with C. So the first thing that I want to do is I want to reflect across the x-axis. Now to do that, my coordinate pair x comma y becomes, and I'm going to move into the space apparently, negative x comma y. So that will change it from here to here. Okay, so I'm mapping this one across. Okay, and we'll move this one over. Okay, then I need to, well, that would get it to here. So my F would be here, my E would be 3 over, and my D would be here. So now I'm looking at a figure like this. And now how do I move it up and over? Well, that would be a translation. So I can move it up and over, translating it. My coordinate pair would then be x comma y would become, well, it looks like I need to move 1 to the right, so it would be x plus 1. And it looks like I need to move, well, 1, 2, 3, 4, 5 up. So this would be y plus 5. And that's how I would do this transformation here. Okay, I would like you to try number 4. We're going to go rather quickly through it, so make sure you type in your answer, and you can check it with mine, and maybe even go back and fix your answer if you want. Okay, so let me do this here and grab a different colored pen. Okay, now that I got a different colored pen here, it looks like when I look at this T, I need to turn it. Okay, so another word for turn would be a rotation. So the first thing that I'm going to do here is a rotation. And how do I need to turn it? Well, it looks like I just need to take it and turn it counterclockwise. So we're going to say 90 degrees counterclockwise. And when I do this, the coordinates move from x comma y. They change and become, it looks like they'll become negative y comma x. And we can use our table that we have in your notes to figure that out. So I'm going to pause the video and graph my first transformation so I can figure out the second one. Okay, so I have my picture now, and I showed some work here on how I changed my initial coordinates to my prime coordinates. And I didn't label all my points because it would have gotten very sloppy. Okay, it would have gotten hard to see. But here I am after one transformation, a rotation. Now, how do I move it from here to here? Well, it looks like it just needs to slide over. But now, how far over does this need to go to get to here? Well, I can just count. 1, 2, 3, 4, 5, 6. So my second transformation is a translation along the vector 6. And it doesn't look like I have to go up any, so 6, 0. It'll just move to the right. That's all for now. Hopefully you had a shot to answer a couple of those questions. Let me know if you need any additional help.